So we have 2x over x squared plus 1, and we need to integrate that with respect to x. Now, with a question like this, we're going to have to use lns, okay? The reason for that is because if we were to bring that x squared plus 1 to the top, it would be a 2x x squared plus 1 to the minus 1. And then obviously we cannot integrate that normally, because if we plus 1 to the power, we get a 0. You can't divide by a 0. Therefore, we can't integrate this normally, and it will become a ln, okay? Now, the thing about this is we also have that 2x. So with that 2x, then how does this all work? Well, what we can do is, first things first, if we know we're going to get a ln, then why don't we just think about, if we're to integrate this, then what could it potentially be? Well, so therefore what we can do is we can consider that y is equal to ln x squared plus 1. What we're doing is we're considering that if we were to integrate this, it would equal ln x squared plus 1. And now what we can do is, well, we know that we need to get a 2x. So if we now differentiate this, let's see what happens if we differentiate this, okay? Now if we were to differentiate ln x squared plus 1, well, if I do the chain rule in my head, what would we get? Well, that x squared would differentiate that, x squared plus 1 would get a 2x. So therefore dy over dx would be a 2x. And then we're times by, of the ln of x squared plus 1, that would be a 1 over x squared plus 1, which equals 2x x squared plus 1. So therefore, if we differentiated ln of x squared plus 1 and we get 2x over x squared plus 1, therefore that means that if we were to integrate 2x over x squared plus 1, it would equal ln x squared plus 1, and then obviously don't forget your c because it's undefined. So now we have this one, we have x over x squared plus 4. So again, we would get a ln because we have the x squared plus 4 on the bottom. So again, let's just consider that this would equal, y is equal to ln of x squared plus 4, okay? Now we'll consider that. Now let's differentiate. So if we differentiate this, what do we get? We would get a dy over dx that is equal to the x squared plus 4 differentiated would give us a 2x times by 1 over x squared plus 4, which gives us a 2x x squared plus 4. Now this one is slightly different because now when we differentiate, we get a 2x over x squared plus 4. But in the question, we only have an x. So what can we do with that 2x to just make it into an x, okay? How can we go from 2x to x? Well, you can divide by 2, or in better terms, when it comes to this, you can times by a half. Because we know that if we have something like, we know that if we do a half times by a 2x over x squared plus 4, then that will give us our x over x squared plus 4, which is what we want. So therefore, if we know that we need to times it by a half, then over here, where we have the y, then we just need to add a half to that. So we should add half. Therefore, if we were to add a half to that, if I just do it down here, we just add a half. And if we add a half, that would make it a half ln of x squared plus 4. And that would actually be your answer. Because if you were now to differentiate a half ln x squared plus 4, you would get your x over x squared plus 4. So then, therefore, if you have x over x squared plus 4, if you integrate it, you'll have a half ln x squared plus 4. So again, with these, this is what we would call the reverse chain rule, okay? Because we are kind of using the chain rule, but we're using it in reverse order. Usually we use the chain rule when we're differentiating, but now we're using the chain rule to help us integrate. And again, because it's undefined, don't forget to add your plus c. So for this one, we have 3 cosine x sine squared x, and we need to integrate that with respect to x. So again, what do we know? Well, we know that when we're integrating, the power is definitely going to be raised by 1. So in this case, what we should do is let's consider y, if we make it y, let's consider y to equal sine to the 3x, okay? Because we know that when we integrate, we're usually going to get an extra power. And now let's differentiate sine to the 3x, okay? So if we were to differentiate this, well, we'd get a dy over dx, okay? What would come out of there? Well, if we think about the chain rule, then we would have, let's say, we would get a whatever sine x is, we would differentiate that. So we get a cosine x, and that will be times by a 3 sine squared x, okay? And you put that together, you get a 3 sine squared x cosine x, okay? And as you can see, well, we've differentiated that. That is exactly what we had in our question. We had a 3 cosine x sine squared x. It's the exact same. Therefore, that we don't need to change anything. Our answer would just be this, okay? Our answer just would be a sine to the 3x plus your c. So now we have sine to the 5 3x, cosine 3x, and we need to integrate all of that with respect to x. So again, we use the same principle. Let's consider that if we were to integrate this, let's consider that y would equal sine, in this case, sine to the 6 3x, okay? And if we were to differentiate this, what would we get? Well, we'd get a dy over dx, and that would equal, well, we would get a sine of a 6 sine to the 5 3x would come out. So we get a 6 sine to the 5 3x. And then we also need to differentiate that sine to the 3x as well. So it'll be times by sine to the 3x differentiated. So what is sine to the 3x differentiated? That would be a 3 cosine 3x, okay? So therefore, dy over dx, that would give us an 18 sine to the 5 3x, okay? Cosine 3x. So this is what happens when we differentiate it. If we differentiate sine to the power of 6 3x, we get an 18 sine to the power of 5 3x cosine 3x. Now, if we've got that, well, in our original answer, we didn't have an 18. So, but in our answer now, we have an 18. So how can we get rid of that 18? Well, to get rid of that 18, because we want that 18 just to go to 1, then we just need to divide by 18. Or, in better terms again, we need to times by 1 over 18. So therefore, our answer would be 1 over 18 sine to the 6 3x, and again plus your c. Okay, so last question of the day, we need to integrate kx squared e to the x to the power of 3 with respect to x. We also have the limits of k and 0. We need to find the value of k. We're also told that this equals 2 over 3 times by e to the power of 8 minus 1. So what can we do here to find the value of k? Well, so for this question, we have the e to the x to the 3. Now looking at that, because we have the x to the power of 3, if we differentiate that, that would be a 3x squared. So we know that, okay, most likely that e to the x to the 3, that will give us our x squared. Therefore, we also have the k as well. Therefore, what we can do is we can consider that y, if we were to integrate this, let's consider that y would equal k e to the x to the 3. Okay? We don't know what k is yet. So let's just consider that all of this, okay, this would give us what we want, okay? So first things first, let's now differentiate this, okay? So if we differentiate this, what do we get? We get a dy over dx, and that would equal, well, we'll get that 3x squared would come out. So we get a 3x squared. Then we also have the k. So let's write that as a 3k x squared. And then with the e to the x to 3, well, if we have e to the x and we differentiate that or integrate it, it just simply equals e to the x. So therefore, this will just stay as e to the x to the 3. So looking at this, we have a 3kx squared e to the x to the power of 3. But in our question, we just have a kx squared e to the x to 3. Okay, we don't have a 3. So what can we do to get rid of that 3? Well, we can just times by 1 over 3. So if we times everything by 1 over 3, that would mean that our answer, let's call it I, that would be a 1 over 3 k e to the x to the power of 3, okay? So that would be our answer. But then we also have limits in this question. We have the limits between k and 0, and we're told that equals 2 over 3 e to the 8 minus 1. So now we can just put in our limits for whatever we have x to work this out. So if we do that, what do we get? Well, we get a 1 over 3 k. Be careful not to change k. K stays the same. It's the x we change to k. So that'll be 1 over 3k e to the k to the power 3. Okay? And that is minus a 1 over 3k e to the 0 to the power 3 is 0. So again, e to the power of 0 is just 1. So it'll just be 1 over k. And we're told that must equal 2 over 3 e to the 8 minus 1. So now if we were to, let's say, factorize this, okay, we can take a factor of 1 over 3k out. So we take 1 over 3k out, and we're left with e to the power of k to the 3 minus 1. Now this looks very similar to what we want, okay? Very similar to what we want. As you can see, we already have the minus 1, and we have that e inside the brackets. So just by looking at this and comparing coefficients, we can tell that, well, if we have 1 over 3k and that equals 2 over 3, well, k has to be 2. And just to verify this, if we have e to the k to the 3 and that must equal e to the power of 8, then what does k have to be? Again, k has to be 2. Therefore, just by looking at this and comparing what you have, we know that k is equal to 2. And that'll be it for this video on the reverse chain rule. We did go over some of the stuff a bit quickly, but again, if you want to go over the chain rule to make sure you understand it, then feel free to watch my other videos. I'll leave links in this video right now. I'll have the chain rule and I'll have the rest of my integration playlist if you want to watch it. But I hope you enjoyed this video and I will see you soon.